Welcome to lesson 5 of unit 9. This is the last factoring method that we need to talk about, and it's a special case that we call D2PS, which stands for the difference of two perfect squares. So that's our goal for today, is to be able to factor this special case expression when we see that we have something that contains a difference of two perfect squares. Okay, so the very first and most important thing you need to do is make sure that you meet the D2PS criteria. We can't use this process or this method if we don't have a difference of two perfect squares. So remember, the D stands for difference. It must be a difference expression, or in other words, we must be subtracting the things. The 2 is for the fact that it can only have two terms, so something minus something. And PS is what allows us to use this method, that all terms must be perfect squares. Okay, so you need to have a difference for subtraction, two terms, and they both must be perfect squares. If all of those parts are true, then we can write and factor our answer in this following process. So we're going to create two sets of parentheses with two different operation signs. So a parentheses with a plus in it and a parentheses with a minus. So something plus something and something minus something. Then, because they're perfect squares, we're going to square root each term in the original expression and then place it in the appropriate spot in our parentheses. Now, if you have a high exponent left over in your parentheses, sometimes they can break down and factor even more, so just be aware of that. Okay, so we have a reminder of our D2PS process. Let's look at the first example together. So again, first and foremost, we want to make sure that we meet the criteria that we need to have. So do I have a difference? Yes, because there's subtraction. Do I have two terms? Yes, 1, 2. And are they both perfect squares? Yes, y squared is a perfect square, and 16 is a perfect square. In other words, I can take the square root of them and get a nice pretty number instead of an ugly decimal. So since I meet the criteria, let's work through our process. First, I'm going to set up my parentheses, one with a plus in the middle and one with a minus in the middle. Now I want to find the square root of each term. So if I look at the square root of y squared, that's y. If I look at the square root of 16, that gives me 4. So now we do have to make sure we put them in the correct order. Since my y squared was first, my y, the square root of that, is going to go first in each set of parentheses. And then 4 is going to go second. That's all we got to do. That's our final answer for our factored form. Y plus 4, y minus 4. Second example, 25x squared minus 100. Again, notice I have a difference, because they're subtraction, of two terms, both of which are perfect squares. I can take the square root and get a nice pretty number. So let's work through our process. Create your two sets of parentheses with a plus and a minus. Take the square root of each term. The square root of 25x squared is 5x. The square root of 100 is 10. And now I just got to make sure I put them in the correct place in the right order. So 5x should go first in each set of parentheses, and 10 comes second. So 5x plus 10, 5x minus 10 is my final factored form. Example 3. Do I have a difference of two perfect squares? I have a difference because it's subtraction. I only have two terms, and both of them are perfect squares. I can take the square root of them and get pretty numbers. So I set up my parentheses with a plus and a minus, and I take the square root of each term. The square root of 100r squared is 10r, and the square root of 9 is 3. So I just put those in my parentheses in the correct order. 10r first in each set, and 3 comes second in each set. So 10r plus 3, 10r minus 3 is my factored form. Okay, example 4, 1 minus 49x squared. I want to factor it. So again, I have a difference, because it's subtraction, with two terms, both of which are still perfect squares, so I'm going to set up my parentheses, because the square root of 1 is 1. So that does still count as a perfect square. And then the square root of my second term, the 49x squared, if I take the square root of both of those pieces, I get 7x. So now, again, make sure we're paying attention to the order. 1 came first, so that's what goes in the first spot in each set of parentheses. And then the 7x goes second. So 1 plus 7x, 1 minus 7x is my factored form. It's not always going to be the x's in front. Sometimes they're first, sometimes they're second. Make sure you're consistent with the order that you have in the problem. All right, example 5, I want to factor 36 plus n squared. So hopefully you recognize, obviously there's two terms, and they're both perfect squares. However, I have a plus sign in between the two. So is that a difference of two perfect squares? No, it's not, which means we cannot use this D2PS process. You need to make sure that you meet all the criteria before you start getting shortcut happy. So this one just doesn't factor. Hooray, we don't have to do any work. All right, last one that we're going to do together for this example. Again, I want to make sure I have a difference, so subtraction, with two terms, both of which are in fact perfect squares. If I take the square root, I get pretty numbers. So I set up my two sets of parentheses with a plus and a minus. The square root of 225 is 15. The square root of f squared g squared, okay, even though there's two variables, we treat it one at a time. The square root of f squared is f, and the square root of g squared is g. So I just get fg. And then again, make sure you put them consistently in order. So 15 goes first in both sets of parentheses, and fg goes second. So 15 plus fg and 15 minus fg are your two factors to make up the factored form. Okay, you have 4 questions to try on your own. So make sure you use the text boxes to type your answer to submit for your grade. And as always, don't hesitate to contact me if you have any questions.